Well, we have a question here that says a soft drink can have a volume of 340 centimeter cubed in a height of h centimeter and a radius of r centimeter. Now, question 9.1 says express h in terms of r. And I'll write the question here, 9.1. We are looking for h in terms of r, meaning h of r. Okay. We have given that the volume is equal to 340 centimeter cubed, and then the height is h and the radius is r. So we do know from the definition that the volume of a cylinder, because a cane has a cylinder form, is given by pi r squared h. That's the volume of a cylinder, and then we can substitute. Okay, the volume is 340, and then pi r squared h. Now we're going to express h in terms of r. To do so, we can just divide both sides by pi r squared, divide by pi r squared. And then this implies that 340 over pi r squared is equal to h. Okay, because here pi and pi r squared and r squared, then we have like h equal to 340 over pi r squared. So that's the formula for the newer function h of r. Now question 9.2 says that show that the surface area of the cane is given by a of r equal to a of r equal to 2 pi r squared plus 680 r to the negative 1. Well, by definition, we know that the total surface area of a cylinder is given by pi r squared, 2 pi r squared plus 2 pi r h. Okay, now we're going to substitute following this formula. A will be equal to 2 pi r squared plus 2 pi r h. And then h is given by 340 over pi r squared. All okay, over that, yes. Now we can multiply here. If I move my board over here, can move all this by here. So this will be a equal to 2 pi r squared plus we can simplify here, pi, and then r and r there, one, because r squared is like 2r, and then this will be 2 pi r squared plus 680. That makes 680 over r. So this means that a will be equal to 2 pi r squared plus 680 r to the negative 1. So this is proven. This is proven. Now we can also do question 9.3. 9.3. Can move it over here. We have like 9.1, 9.2, and then now 9.3. The question says, determine the radius of the cane that will ensure that the surface area is a minimum. Now, so we're going to determine the radius of that to ensure that the surface area is the minimum. So we can find the minimum of the surface area by making the derivative of the function equal to 0. Okay. So I'm gonna write here 9.3. 9.3. So over here we're looking for r, okay, such that the function a of r is the minimum. We can obtain the minimum if we set the derivative of the function equal to 0. So over here, what we have, like, we do have that a prime will be equal to 2 times 2 times pi times r to the power of 2 minus 1 plus what we have here as -1 times 680 r to the -1 minus 1, which will make 4 pi r minus 680 r to the -2. And then this will be, excuse me, if we take like, now this must set this equal to 0, okay? This is equal to 0, and then we have like 4 pi r minus 680 r. Okay, with the negative power here can be written like over r to the negative r to the positive 2. Then we can move this part, this negative part, over on the other side of the equal sign, and then this will be 680 over r squared equal to 4 pi r. Then understand that this has a denominator of 1. We can cross multiply this, and then this will be 4 pi r cubed equal to 680, I suppose. I meant to say. Now we can divide both sides by 4 pi. I divide here by 4 pi, and there. So then let's see, tablet. I divide this one by 4 pi, and then I divide here by 4. Oh la la. I divide here by 4 pi, and then also by 4 pi. Now, that means this will be simplified, and then I left with r cubed equal to 680 divided by 4. This is equal to 170. Okay, so that makes 170 over pi. And then to find r, we can just find the cube root of 170 over pi. And then r will be equal to, let's say calculator. The cube root will press shift, and then r, and then 170 over pi. You press shift again, and then that button, and then we got like, this is equivalent to 3.78 centimeters. That's 3.78 centimeter. That's the radius r. Thank you.